Okay, let's unpack this. Global challenges like climate change, well, they can often feel overwhelming, maybe a bit abstract. But what does it truly mean for specific places, for vital industries on the ground? How do communities actually, grapple with these realities?
That's really the core question we're diving into today.
Yeah.
Our focus is Thailand and how it's navigating a changing climate. Specifically, we're looking through the lens of its crucial water resources and its incredibly important tourism sector.
Right.
We've pulled together some fascinating research, everything from these detailed flood forecasting systems in major river basins, right up to studies on how tourist destinations are strategically adapting to new weather patterns, essentially.
So our mission for this deep dive then is to pull out the most important nuggets of knowledge from these sources. You're going to hear about surprising facts, some ingenious solutions, and hopefully some, well, aha moments about how science and proactive planning are coming together to face these challenges head on. It's a real-world look, isn't it? At how critical information gathering and strategic adaptation actually build resilience.
Absolutely.
Okay, let's set the scene first. The big picture of climate change in Thailand itself. Our sources highlight some pretty significant trends affecting the whole country, not just isolated regions. What are the main patterns we should be aware of?
Well, okay. Over the past, say, 40 to 50 years, Thailand has definitely seen a notable increase in overall temperatures.
Hmm.
What's particularly interesting, though, is that the average minimum temperatures, they're rising faster than the maximum.
Oh, really?
Yeah, which narrows the daily temperature range.
Mm.
And in the bigger cities, like Bangkok, you can really see that heat island effect playing out, where all the concrete and buildings absorb and retain more heat. It makes those urban areas significantly warmer than the surrounding countryside.
Okay, so definitely getting warmer, but what about rainfall? I get the sense it's not as simple as just, less rain overall.
That's exactly right. And that's where it gets really interesting and honestly quite complex. The data actually shows a trend of decreasing total annual rainy days and shorter periods of continuous rain, too.
Fewer rain days.
However, the intensity and the total volume of heavy rainfall events, that's actually increasing in some areas. So it creates this really challenging paradox. You've got a higher risk of flash floods when it does rain,
Right.
often followed by prolonged droughts in different parts of the country.
Wow. So fewer rain days overall, but when it rains, it really pours. That's the dynamic.
Precisely. And to add another layer here, the frequency of tropical cyclones entering Thailand, that's actually decreased over the last 6 decades or so.
Decreased. Okay, that's unexpected.
It is, but the cyclones that do occur have become more intense since the 1970s, and this contributes directly to that pattern we were just talking about. Severe floods, alternating with these extended dry spells. And of course, we can't ignore rising sea levels. Areas like the Andaman Sea, the Gulf of Thailand, they're seeing increases of several millimeters per year.
It really sounds like a volatile mix of extremes. What are the actual states here? Especially for something as fundamental as, say, agriculture.
Oh, the stakes are incredibly high. Our sources estimate a potential for over 25% agricultural damage just within the next 50 years.
25%.
Yeah, if water management isn't, robustly addressed, that's a massive potential economic and societal impact.
That really brings us to specific regions then and how they're tackling this. Let's maybe zoom in on the Chiang Mun River basins, northeast Thailand. Our sources describe them as huge, vital agricultural areas. What makes these basins so, well, challenging to manage?
Well, first off, they're enormous. They cover over 2/3 of the Northeast's total basin area. And geographically, they present a unique challenge. You've got these high plateaus up at the headwaters,
Okay.
which lead to massive water runoff during the rainy season. All that water then flows down into these flat, shallow, and winding downstream areas with naturally low drainage capacity. So this combination, as you can probably imagine, frequently leads to pretty severe flooding.
Right, the water just piles up. And it's not just managing too much water during floods, is it? These areas also struggle with getting enough water for farming, especially since, you said, most rely on rain-fed agriculture.
Exactly. It's that dual challenge again.
So how are they trying to tackle this, both the floods and the scarcity?
The solution really lies in developing advanced technology, specifically a decision support system, or DSS, and a flood forecasting system, or FFS. And this isn't just about predicting the weather in isolation. It's an integrated system.
Integrated how?
It combines real-time monitoring with these quite sophisticated models. It takes rainfall predictions from the Weather Research and Forecast Model, the WRF,
The WRF, yeah.
and it links them with a detailed river model
Yeah.
to estimate the actual water discharge downstream.
That WRF model itself sounds pretty powerful. What sort of accuracy are they actually seeing with these forecasts in the Chi and Mun basins?
It's actually quite impressive. The WRF model, it can forecast up to 7 days in advance. For these basins, the initial test they ran back August to November 2013 showed a forecasting accuracy for rainfall of about 73% for day 1.
73%. Okay.
Yeah, then 70% for day 2 and 65% for day 3. What's also really critical is that these models are built to distinguish between the main river channels and the surrounding floodplains. They simulate how the water actually moves between them, which is key for flood prediction.
So it goes beyond just predicting if a flood might hit or when. What broader capabilities do these advanced systems offer the decision makers on the ground?
Well, this is really about comprehensive water management. That decision support system, the DSS, it helps the decision makers by processing all this complex data. It compares the forecast results against predefined warning criteria and then presents it all in a clear, actionable format. Now, it's still under development, but the preliminary results look very promising. The ultimate goal is to enhance efficiency not just for flood prevention, but also for proactive drought monitoring and management too. It's really about empowering communities, giving them the info they need to make informed decisions, to reduce damage and, crucially, ensure water availability.
Okay, speaking of strategic water management, let's shift to another fascinating case study you found. The Mahengad Sambunshal Dam up in Chiang Mai. This is a multi-purpose dam built through a royal initiative, you said, and it's absolutely crucial for local agriculture there. How are they analyzing its future under climate change?
Right. This study specifically looked at how climate change will likely impact the inflow into this particular reservoir. To do that, they used regional climate models, or RCMs, under 2 different future scenarios. You might have heard of them, RCP 4.5 and RCP 8.5.
RCP, yeah, those sound familiar, but they are a bit technical. For listeners who might not be deep into climate modeling, can you quickly break down what those numbers 4.5 and 8.5 actually mean?
Absolutely. Good point. So RCPs, they stand for Representative Concentration Pathways. They're basically scenarios used by the IPCC, the big international climate change panel. They project future greenhouse gas concentrations based on different assumptions about climate policies and emissions. Got it. So RCP 4.5 is generally seen as a moderate emissions scenario. CO2 emissions peak around mid-century. It leads to about a 1 degree Celsius global temperature rise from 2005 levels by the year 2100. RCP 8.5, on the other hand, that's often called the worst case or business as usual scenario. It assumes rapidly increasing emissions continue. That could lead to a much higher global temperature increase, potentially 4 degrees Celsius by 2100.
Okay, so higher number generally means a more severe projected warming impact.
Generally, yes. But what's genuinely surprising, and maybe a bit counterintuitive here, is what they found specifically for the Manga Dam's future rainfall. Under that more moderate RCP 4.5 scenario, rainfall is projected to decrease steadily by about 0.38% in the near term, 2026-2050.
Okay, a slight decrease.
Then 0.40% between 2075 and 0.47% decrease between 2076-2099, all compared to the baseline period.
So a steady, gradual drying trend under the moderate scenario. What about the worst case, RCP 8.5? Does that just mean an even steeper decline in rainfall?
Well, this is the fascinating bit. Not initially. Under RCP 8.5, rainfall is actually projected to see a tiny increase, 0.01% in the near future, from 2026 to 2050.
An increase, even under the worst case emission.
The very slight one, yes. But then it starts to decrease by 0.15% in the mid-future, 2075, 2075, and 0.23% in the far future, 2076, 2099. So that brief initial increase, even under a severe scenario, it just reveals the incredible complexity of these climate models. Planners can't just rely on simple linear assumptions about future weather, you know?
Absolutely. It shows why these detailed projections are so crucial.
Exactly. These precise, nuanced projections are incredibly valuable for the water resource planners. They inform that strategic planning, the efficient water allocation for farmers, especially when resources are already limited.
It's really clear that sophisticated planning is crucial for water, which is, the lifeblood of agriculture. But what about Thailand's other major economic lifeline, its incredible tourism industry? How does all this climate variability impact a sector so dependent on, clear skies and beautiful natural spots?
Yet tourism is highly vulnerable. I mean, think about it. Climate dictates the quality and the length of tourist seasons. Right? Clear skies for those island getaways, or crisp, cool weather for destinations up north.
It's definitely.
It directly impacts the natural attractions themselves, coral reefs, water levels in rivers for rafting maybe.
Yeah.
And it can also exacerbate undesirable things like disease outbreaks or even wildfires.
And when these climate shifts hit tourism, is it mostly felt as like direct cancellations, a tour gets called off, or are there more subtle sort of systemic ripple effects through the whole industry?
Oh, it's absolutely a whole chain reaction. Threats like drought, rising temperatures, sea level rise, those changing rainfall patterns we talked about, they ripple through the entire tourism ecosystem. They affect outdoor activities, obviously, but also both natural and man-made attractions. Transportation networks can be disrupted, even essential utilities like energy and water supply for the tourists themselves. It's really foundational.
Yeah, I can see that. And we've certainly seen some dramatic examples globally, haven't we? Our sources mention the devastating coral bleaching on Australia's Great Barrier Reef due to rising ocean temps. And Venice, Italy, experiencing floods covering 70% of the city back in 2019 because of sea level rise.
Exactly. Those are really stark reminders that climate change is already affecting iconic destinations all over the world. There was a UNESCO survey of World Heritage Sites. It found that 72% of the countries surveyed reported climate change impacts on their sites. Natural sites tended to be more affected than cultural ones, suffering from specific threats like coastal erosion, severe storms, and of course, rising sea levels and floods.
And Thailand is clearly not immune. Looking at the country's tourism risk map, it shows many provinces are highly vulnerable, including some we mentioned earlier in the water context, like Konkan, Nakhon Ratchasima, Ubon Ratchathani in the northeast, and Chiang Mai up in the north too.
That's right.
So, given this broad vulnerability across the country, who actually adapts best within the tourism sector? Is everyone equally able to cope?
That's another important insight from the research. Our sources reveal that different players have quite varying adaptive capacities. Tourists themselves, maybe surprisingly, have the highest capacity because they can freely choose different destinations, different travel times to avoid bad weather.
Makes sense. They're mobile.
Exactly. Large tour operators, with their more flexible assets, they have a moderate capacity. But it's the local accommodation providers, the hotels, the resorts, and the small local tour operators. They're the most vulnerable, mostly because they have significant investments tied up in immovable assets, buildings, local infrastructure.
Yeah, that really drives home how the burden of adaptation can fall disproportionately on those smaller local businesses. So, what are the solutions being looked at? How are places actually trying to adapt?
Well, adaptation comes in many forms. It's really a whole toolkit of strategies. We're talking about technological fixes like early warning systems for sure,
Yeah.
building new water reservoirs, maybe even desalination plants where fresh water is scarce.
Okay, the tech side.
But also changes in management, things like water conservation plans or developing a wider variety of tourism products so you're not reliant on just one thing. Policy shifts are key. More research, education for staff and guests, even encouraging behavioral changes among visitors. It's all part of that toolkit.
Can you give us a real-world example of this adaptation actually happening somewhere in Thailand?
Yeah, definitely. The Chiang Rai province up in northern Thailand is a prime case study. It was chosen as a pilot area for the National Adaptation Plan, partly because its natural attractions are sensitive and it's highly seasonal. It's a really popular winter destination.
Right, people go for the cool weather.
Exactly. So the key threats it faces are pretty clear. Warmer, shorter winters, and also the potential for localized flooding during intense rains.
So, faced with warmer winters and potential floods, how are they trying to reinvent their tourism offerings in Chiang Rai to make them more climate resilient?
The proposed solutions for Chiang Rai are quite strategic and I'd say pretty ingenious, actually. They are looking at repositioning their marketing, naturally, to promote year-round tourism, not just winter. But here's the really interesting part, maybe the aha moment. They're actively developing new man-made attractions, things that don't rely on specific weather conditions.
Like what, for example?
Think cultural sites, food tourism, which Thailand excels at, or health and wellness tourism, things people can enjoy regardless of whether it's cool or warm, rainy or dry. The idea is also to help those small local businesses diversify their income streams so they're not solely dependent on, say, winter trekking. The core concept is creating tourism offerings that are less dependent on the climate, but still retain that local identity and leverage local resources.
So it's not just about defending against climate impacts. It's about actively reinventing the local tourism economy.
Precisely. It's a proactive approach.
That sounds like a really comprehensive approach. But what's the biggest hurdle? What's stopping this kind of adaptation from happening more widely across Thailand's tourism sector?
Well, the biggest challenge that the research highlighted is that many Thai tourism operators, particularly maybe smaller ones, still lack full awareness of the full scope of climate change impacts. They tend to focus more on, say, low-carbon initiatives, like saving energy, which is good.
Important, but not the whole picture.
Exactly. It's
Uh-oh.
not the same as broader adaptation strategies for resilience. So the urgent need really is for government, the private sector, and academic institutions to work together to provide robust support through funding, crucial infrastructure improvements, help of marketing these new climate-resilient attractions, and ensuring everyone has access to accurate, usable early warning systems. It's about building that capacity and understanding.
Right, a fundamental shift in thinking is needed. Okay, so we've taken quite a deep dive today into this complex interplay of climate change, water management, and tourism in Thailand. We've seen how these advanced forecasting systems are being developed for major river basins, how specific dams are being analyzed for future water availability, sometimes with surprising results, and how that critical tourism sector is both really vulnerable but also actively seeking these innovative ways to adapt.
Yeah, and what's fascinating here, I think, is how these diverse efforts across different sectors, they reflect this growing understanding that adapting to climate change isn't just some distant concept anymore. It's an immediate, ongoing process. It involves intricate scientific models, yes, but also careful planning and real on-the-ground implementation to build resilience. It's about proactively shaping a future, not just, reacting to whatever comes.
That really raises a final important question for you, the listener, to consider. How do these sophisticated models and strategic plans, from predicting localized floods in a river basin to completely reinventing a region's tourism economy, how do they fundamentally change our whole approach to environmental challenges? What really stands out to you about how communities are moving beyond just predicting the future and actually starting to actively build a more resilient one?